Hi everyone. I'm Andrew, and I'm one of the co-organisers of the meetup group here, and you have the dubious honour today of hearing me talk about an introduction to data lakes, because this is something that, as I was just saying in the preamble, I've been banging on about for a while. So I thought it's a good time for me to just try and collate this into a presentation, and then we can talk through it. So what we're going to cover today, we'll talk about a little bit about what is a data lake, but a lot of what we'll talk about is really where they fit in the big picture of data platforms and analytics. And so, start with that. We'll talk about why you need one, what you put in one, a little bit about how you'd build one, but not to a great depth, not to anything that would sort of cause anyone concern at this time of night. Some of the things you do when you've got one, and some problems you should avoid, and then I'll round off by talking about a case study of one of the solutions that we've been involved in with my company. That has data lake quite close to its core, using which is an IoT solution with data lakes. So a little bit about me. Here I am. So I'm Andrew. I've been in IT for over 20 years, but originally I was an aeronautical engineer, and although most people think most people think like aerodynamics is about blowing smoke in smoke tunnels, in wind tunnels. In fact, 99% of aerodynamics is numerical calculus, and so I was pleasantly surprised when I found out that 99% of machine learning is numerical calculus, because it always made that a lot easier to understand. But in the meantime, most of what I've been doing is data, data platforms, data integration, moving data around, and that sort of thing. And very briefly, I work for a company called 345 Technology, which I co-founded in 2015, and we focus on three areas, as we call it: integration, which is moving data around and automating processes that use data; data platforms, which is storing data and being able to find and retrieve it again, and take care of the quality of it and that sort of thing; and data analytics, which is making sense of all that data. And when you put and the sort of the term we use when to put all those three things together is data engineering. So what we're talking about today, what I'm talking about today, very much fits in the middle box, the green box of data platforms. So firstly, what is a data lake? And what I like to say is it's a data store designed to hold gargantuan amounts of data. And I think the term gargantuan is the one that's significant, because as we all know, we live in a world of big data. It's almost a we almost say it flippantly now, and most people don't really even drill into what that actually means. But ever since the arrival of the internet, big data has been inevitable, and that's because people are data generators. And so everything we watch, everything we read, everywhere we go, what we buy, the videos and photos we take on our phones, even what we say, it's all being captured, it's all being stored, it's all being mined. And then everywhere we go, our offices, our shops, the vehicles we travel in, they're all generating data, and that's also potentially being captured, stored, and mined. And so we need to think about what does it take to be successful with big data. So the first step on that is that you need to store it. You then need to be able to make sense of it, and thirdly, you need to the whole point is that using data from the past kind of informs what we do now and in the future. So there is no point to big data unless we're using it to make the future better. But we can't do that if we can't make sense of it, and we can't make sense of it if we haven't stored it in the first place. So the whole thing with data lakes then is really where do we store it, and in particular, how do we store the really big quantities of data that are all around us all the time. And not only is there a large quantity of it, but also it often doesn't come in the format that's easy to use, and it doesn't come, it can come in different shapes and sizes, different formats. So we need somewhere that we can put all this that is able to hold that, and that would be your data lake. So one of the other things I also find useful to think about is how we deal with data versus time, and that's because how we deal with data in the short term is very different from how we deal with data in the long term, and this is the same for humans as it is for computer systems. That in the short term we are really interested in actions and decisions. If we have a finance system, here's an invoice, can I pay it? You might have a warehousing system, here's an order, can I ship it? A lot of line of business systems are built around very specific goals. Generally speaking, the data size is quite small and it's focused, and the data is about the thing that's being processed right now. However, if we look at things over a longer term, what's important is that we gain understanding and perspective. When we look over a long time frame, we don't necessarily have a specific thing we want to get out of that information, other than we ask questions and we try to find answers, and we look over a whole data set, and this gives us the ability to learn. Now there's a very big difference between computers and humans, and that is that humans filter almost everything out almost straight away because our brains simply aren't big enough. And that's why what we're used to doing is curating knowledge. So we throw almost everything away, but we tend to curate some things we want to keep. And we can't help it. We do it with everything. We do it with textbooks for kids learning in schools. We do it with playlists on Spotify, because generally, there are too many things on Spotify to even cope with. So people create playlists to curate, good music, and then throw everything else away. Almost every area of life, we are filtering and curating and discarding almost everything. Now with computers, it's different because computers have the capability of storing everything. Okay, it comes with a cost, but we can potentially store everything. And what that means is that when we're looking for meaning, we can continually reframe the questions we're asking. We can reframe the data sets we're building. And we continually learn more, and we can go back to the source data rather than going back to a filtered or curated data set that may not have everything we want. And again, it's only if we've stored it in the first place. So, just to illustrate this, it's some people I work with have are on tenterhooks every Black Friday because it's the busiest online shopping day of the year. Very, very high amount of load. You get you've got e-commerce sites, payment systems, finance systems, warehouse systems, all doing their thing, and they're all just trying to get their things done on the day. Whereas, some questions you might look at in the long term might be, which systems are most likely to have errors on Black Friday due to load? How much capacity do we have? Is that changing over time? Are we getting better able to cope with things over the last few years than before? And that requires us to have that big data set, but also data that's collated from many different parts of our organization so that we can tie them all together. So, okay, so the big data principles are really, data can come from anywhere. Excuse me, I'm just gonna have a slurp of tea. Data can come from anywhere, in any format, and it's all valuable. But also, when we capture it, we don't necessarily know what value we're going to make of it later. So we capture it all so we can understand it later. And the more we learn, the better our questions can be. So, and the better understanding we can get from our data, the better the decisions we can make. But that's, and that's based on not only having better data, but also better processes to ask the right questions and get the right analysis. So there we go. That is why you'd have a data lake. Capture everything, understand it later. And one of the key things of this is that we have to make it cheap enough to hold everything. There's no point in capturing everything if it makes us bankrupt. So I think one of the other things that we will talk about in a moment is really the cost aspect of data lakes, as opposed to just the technology aspect. So, why not use existing types of storage? So if we look at things like Azure Table Storage, which is actually a key value. I've put table column here, but it's actually a key value store. These are really fast kinds of storage, but they're quite narrow in terms of what they can do. Cassandra's a bit like that. Cassandra's really good at storing stuff. It's not as good about getting it back again, but there are many data stores that are really, really fast, but not particularly flexible in terms of how we use them. And those would be the key value stores. Then we've got sort of blob storage, or file storage as it would be in old money. So blob storage by itself doesn't make a data lake, although it's an important part of it, because it's great. Blob storage is really cheap. It's just here's a key, put some binary there, and it's great for raw object storage. It's great for storing almost anything that is a binary file. Just stick it into blob storage. However, one of the problems with blob storage is it's quite dumb. You can't necessarily easily find something unless you know where the thing is that you're looking for. It's very difficult to find things later. And then of course we've got other types of data store, which is relational databases are really sophisticated. You can put really complex, highly structured, highly consistent data models in there. You can have transactional integrity. There's all sorts of good things about relational databases, but once you've designed them, they're a fixed structure that you just can't force everything else into. And then also, if we look at document databases, like one of the most popular document databases is MongoDB. It's great, hugely scalable, consistent at a document level, but again, it's collections of things. And if it does, and if you're trying to find a format to store anything, whatever it is, those kind of collections don't necessarily work. And then the last type of data storage that we can talk about is like graph models as well. They're really important and really powerful because in a graph database, the value of the data is in the connections, it's in the relationships between things. And a lot of the concepts of these came out of social media, because who's friends with whom, where have you been, where have you eaten, who's liked this photo. All those things are just the connections in them. It's not just the things itself, but the connections and the relationships between them. They're very powerful. But again, it's not the sort of thing that you store. You can't store massive amounts of data in these. Although they are really interesting. I think maybe a future talk will be on graph, just what you can do with graph databases, because they are, for example, a lot of again going back a little while, did a project for the police, and a lot of police intelligence uses graphing models to, so that here's a person, they call it POL, person, object, location, and event. So that when you say, okay, here's a person, here's a car, they're in this place at this time, and then something happens, you can then map all those things together. Great stuff. Anyway, slightly getting off topic, but you've got all these great databases, but they're all made for specific purposes. They're all optimized for doing a particular job, usually in relation to a particular type of app or a particular type of workload. And they're generally performance optimized. And so what they tend to be is they tend to be, relatively speaking, expensive and specific. So they don't fulfill what we want from a data lake, because they're not cheap, and they're not going to handle all the different sorts of data that we want. So whilst they've all got their place, they're not quite, that's why we don't use those. So under the bonnet, what actually is a data lake? So we kind of got this far without saying what a data lake actually is, but it's because with a lot of tech, it's not easy to actually visualize. It's not easy to visualize something that's in the cloud that is just a load of servers somewhere with stuff on them. But really, a data lake at the basis of it is a hierarchical blob store and a data catalog. So the point of the thing that makes a hierarchical blob store important, as opposed to just a blob store you just chuck anything in, is because you can apply operations at a level of the hierarchy, whether that is you're creating whether that is permissions, or whether that is being able to put in certain types of data at certain levels of hierarchy, or service different areas of a business at different levels of the hierarchy. It means that from the point of things like security, or shall I move all this data, or shall I delete all this data, or shall I extract all this data to do analysis on it, having a hierarchy really helps. And the other thing is having the data catalog, so that the point of a data catalog is that we can find things later, and we have metadata that points to the underlying object, that allows us to extract what we want. And another interesting thing on this is that you can actually put things in with a very small amount of data in your catalog, and actually have processes coming off that enrich it. So one of the things that you find in a lot of people wanting to do now is, if they're putting documents into a data lake, you can, so something like, let's say you've got a PDF or a PowerPoint presentation, you can actually crack those documents open, pull out all the images, run AI on those images to find out what they are, and create metadata on those images, and then add that to the data catalog, so that you can actually say, okay, here's a PowerPoint presentation, but it's got a photo of a dog in it, or something like that. And you find that a lot of search technology now is doing that more and more, that people store things, and then you have background processes that are enriching the data catalog. And even you find it with Google, that sometimes if you're searching for something, you'll find a link to a PDF that has a particular thing inside it. And that's because they've gone and done this thing of, it's almost like this thing's been in a blob store, and it's then being trawled for the metadata that goes with it. Okay, another area that people often say is, what's the difference between a data lake and a data warehouse? Because both of them are often seen as being the roots of analytics. But really, one of the main differences is that a data warehouse is designed in advance. So what it's highly structured. Usually they have what they call the star schema, which is a sort of a central table that has the facts in it, the information you want to report on, and then it has the dimensions, which are really how you slice and dice that information. And they're structured. You decide in advance what you'll hold, and they're great for things like financial data and sales data, and the sort of things that don't really change very often, because you've decided in advance what you're gonna hold. That's based on usually what you want to report, how you want your reports to look. And the data, the source data is cleansed and transformed before it goes into a data warehouse. And that's a key thing. It's not just you know, ETL is the extract, transform, load. So you extract, you take it from the source system, transform it into the format of the destination, and then load it into the destination. What we do with the data lake is very different in that we store everything, and we don't worry about the structure of it on the way in. We hold, as I say, we hold everything, decide what to do with it later, which I think I've said about 4 times now. And then, but what we can do is we can store it, and then we can cleanse it, enrich it afterwards. And so that what that's often called is ELT, which is extract, load, and then transform. So we're just we're just capturing it as soon as possible, and then have the transforms come a bit later. Sometimes even at the point when you want to use it. There's kind of a bit of a health warning there, in that we normally say everything goes into your data lake as raw as possible, but sometimes we do need to sanitize things on the way in. But that's not because we're trying to filter out data because we've already decided what the answers are. It's just things like data protection, particularly security. Do we have to redact this information? That sort of thing. Depending on how the security is set up, and depending on what the regulatory environment is, you might have to do a bit of redaction for things on the way in. So, what would we put in a data lake? Well, it's a bit glib to say everything, but the idea is that we can pretty much put anything in. I mean, one of the more I look at data lakes, the more YouTube basically is a data lake for video, for example, and that does exactly a lot of what we've just been talking about, in that people upload video, a background process runs, which actually runs AI on that video. It will produce a transcript of it. It will check whether you're a terrorist and all those sort of things, and then it will be enriching the data catalog associated with that, so that people can then find it. And then actually a really trivial part of YouTube, in some ways, is the actual player. And okay, that's probably simplifying it a bit too much, because there's a lot of really clever stuff about handling the scale and that sort of thing. But for businesses, video, audio, and images are becoming increasingly important. So audio, for example, if you've got a call center, you're generating a lot of audio, and people are storing that for, people used to sometimes just store that for a particular period of time, but again, regulated industries might have to store that for years and years and years. And now there is the AI there to mine it. So if you've been taking your audio, storing it for a long time, you may be able to get particular insights out of that you didn't even know about a few years ago. And also images are becoming increasingly important, because fewer and fewer people write notes on what's on their whiteboard. Now they take a picture of it, but then being able to process that later, take the text from it and understand what was on it is also some of the things we're doing. Also in manufacturing, for example, video, audio, and images are being used for quality control. So again, if you look at something like one project we were talking to some people about was they were interested in welds and basically or soldering on circuit boards, and basically from the sound that a soldered joint makes, you can tell whether it's good or not. You can tell whether you've got a dry joint or a good joint by the sound, but also from the image. But if you put the two together, you get a really, really highly accurate view of whether something is good or not from that, and it's completely non-invasive. But that also requires you to have the data set to build out the machine learning in the first place. Logs from computers are a big one, so for checking for sort of technical systems, for the reliability, and also for IoT, telemetry is a massive source. Again, we'll talk about that in a moment. And also all the archive data from your line of business systems. So a lot of line of business systems, we only keep a certain, maybe a year or two's worth of data in them, so they don't get too big, so we can keep the performance. But all that previous historical data, that can all go somewhere. So you can put all these sorts of things, and it's really then a question of how you use that data. So I ran out of inspiration for pictures by this point, but why would you build one now as opposed to before? So I think one of the big differences, and one of the reasons why I'm quite excited about data lakes, is that the cloud providers have made it very easy to build data lakes. Whereas if you were building one yourself, it would be quite hard. I mean, particularly if you actually had to buy the servers and all that sort of thing, it would be hugely expensive and very difficult. You'd be talking about £1 million SANs and 100 servers and that sort of thing. You just the scale that you might have to build would be enormous, and the engineering effort that goes into that. Whereas now you can provision a data lake on from a cloud provider like Azure or AWS, and you can be up and running in minutes, and you don't have to even worry about how the whole thing fits together, because they'll look after that for you. So actually, the ability to hold all this massive amounts of data is so within reach now. It's almost like there's no excuse not to be seriously looking at this when you're looking at your the data architecture of your business and that sort of thing. And next, we're going to talk a little bit about price. So here's some examples of Azure Data Lake pricing. I've chosen the Azure one to show because it's a lot more understandable. Because with AWS, when you build a data lake, it provisions all the data lake resources, but charges them all separately, whereas Azure just gives you a price. But just if you look at the bottom line on this, that if you're wanting to buy a petabyte of capacity, but you don't mind the speed and you want the archive thing, a petabyte for £604 a month is actually quite mind-boggling. I mean, a terabyte is 1,000 gig, and a petabyte is 1,000 terabytes. I mean, that's an awful lot of data. I mean, just as a sort of a scale, one of the financial companies we work with, they're storing 100 million pieces of data a day, and over the last 7 or 8 years, they've got maybe 20 terabytes of in terms of business transactional data. So petabytes is that's big. I mean, the only people I've spoken to that are doing that I know of that are doing petabytes all the time are the Met Office. I mean, all that weather data is just vast, and it's of that sort of scale. But if you're big companies, that particularly if you're moving from if you're moving from taking a few measurements on something to taking a video of a component for quality control, the data storage is going to start adding up. But if you look at this now, the prices are certainly achievable by most businesses. One of the things that looking at this from the point of view of price, it does depend on a few things. So it depends on speed. I mean, you see this here, this example here, it's got hot, cool, and archive, which is obviously the speed of retrieval. So hot is it's on SSDs, and you can get it quite fast. Cool, I think, is it's on spindles, and archive is, well, I'm not sure where archive is. That might be stored offline, and you actually have to go and get, they actually have to mount a drive to plug it in. The other thing is redundancy. I mean, we sit on, whether you've got local redundancy or global redundancy. Some cloud providers have different prices per region. So there's a few variables to understand how expensive things are, but given the fact that you can provision a data lake within minutes on a cloud provider, and for a lot of businesses, it will cost you hundreds or tens or hundreds of pounds a month for the sort of data you might want to store. That's actually amazingly achievable. So now just let's think about some of the headaches we want to avoid. So again, just by having huge quantities of data and all your data, one of the things we want to avoid is having security holes. So again, designing the data lake from the ground up with the security model in mind, particularly, and this is where the hierarchy really helps, because if you've got the right hierarchy and applied permissions at the right levels, then you can have a reasonably workable security model. So that's a really important one. The next one is the regulatory concerns. So I mean, obviously things like GDPR. So when people say, "Where's all the data on me?" If you've just randomly, randomly inserted data over, all over the place, that can, that GDPR aspect can be really difficult. And okay, there's a couple of ways around that. One of them is to make sure that the data catalog identifies the people where personally identifiable information are, or it's to cleanse that data on the way in so that you know that it doesn't have any personally identifiable information associated with it, which might be okay if you're more interested in stats rather than individuals. Data sovereignty is another aspect of regulation, because data sovereignty is making sure that you know the country in which the data resides, so that particularly a lot of government work and particularly military work they're very hot on that side of things. They want to make sure that the data doesn't leave either doesn't leave the country or doesn't leave a particular region. And again, cloud providers might put their data, if you don't specify it, they might put the data where it's convenient for them, not where it's not where you're not where you need to have it. And this one here, build a lake, not a swamp. So if you've got tons of data and you store it, but you don't categorize it properly, you don't populate the data catalog properly, you just end up with just a load of stuff that you can't use, and that is a data swamp, not a lake. So again, a lot of the things to do on that is to make sure that when you write data, that you're putting the appropriate things in the catalog so that you can find it again. And the last one is to understand the cost model. So having just said how cheap data lakes are, the compute for particularly if you're doing analysis off the back of it and extracting big data sets and crunching those, that's often where a lot of the compute cost is. So if you're spinning up enormous Hadoop clusters to crunch terabytes of data, that can actually be where all your costs add up, not the actual storing the data in the first place. So you just need to understand what speed of data you need, and again, the better you can be at categorizing your data, the more you can be precise about extracting just the data you need, so that you don't need as much compute power to crunch that in the future. So just understand the cost model so it doesn't appear as a surprise is probably the last one of the headaches to think about. And given the theme of the meetup group, really, where does data science come into this? So so I look at this in two different ways. One of them is the data lake as a source, and the other one is the data lake as a destination. So obviously, from as a source, you can be extracting data sets and using that for statistical analysis, streaming analytics, that sort of thing. And you can also be building data sets for machine learning. And so that is the source of the data. But the other one is, like I said before, it's the enrichment, that all the processes you can run on your data to enrich it, which could be language translation, it could be classifying images, it could be getting transcripts of audio, it could be just just understanding, just understanding the content and having sentiment analysis on it, all those sort of things, and just enriching the data sets so that we take data out of the data lake, we perform operations of it, and then we put enriched data back in. So that's the data lake then becomes a destination for the enriched data. And right, so what I'm going to do now is finally just talk through a solution that we've worked on, and this is an IoT solution for a mining client. So this mining company, what we have in the top left, which is the red blobs, is their IoT devices. So they've got all sorts of pipelines, equipment, all those sort of things in the field, and these are all transmitting telemetry. Sometimes they're connected via a SIM card and they're just transmitting us all the time. Sometimes they're in the middle of nowhere and they have to wait for a satellite to go over. So they tend to have a smart edge device that gathers up the day's worth of data and then tries to burst it in one go. So, but they, if you've got devices that may be measuring temperature, pressure, flow, acidity, noise, all these, air quality, wind speed, there are all sorts of sensors measuring things, and they can be measuring, on a per second basis. That's a lot of data that you could potentially be hoovering up. So in this case, obviously, they went through the internet as represented by the cloud on the diagram, and this solution was built in Azure. So we use something called IoT Hub, which effectively is a load of APIs that make managing IoT devices a lot easier. But it also allows, just provides very scalable API that can absorb large amounts of data very quickly. And from the IoT Hub, that went on a service bus. So the top layer really is the integration part of the solution. So that's just capturing, having the APIs to capture the data and then getting those onto a bus so that all that data can be processed asynchronously, so that so you don't have to just you don't have to wait for all the back-end processes. That all the devices can send their data. As soon as it's confirmed, they can disconnect and go get back on with their business. So once we got data on the service bus, there were two destinations for it really. So one of them was feeding into a relational database, because we wanted a small subset of the data for reporting purposes, and that was only really what was the last month's worth of data, just so that people can look at what's my equipment doing now, and that data kept on getting archived regularly, so that to keep the data set small. But there was apps that were just looking at that data set and reporting on what's the pressure now, what's the temperature now, how's that varied over the last day. But the bulk of the data goes down the right-hand side into the data lake, so that it's just capture everything. So there's just gigabyte upon gigabyte of telemetry data going into the data lake every day. And then what we were able to do then was to use an ETL tool. So again, it's like Microsoft's cloud. ETL is Data Factory, and that feeds in, and that was in this case feeding into machine learning experiments, so that we could look at things like, when is this piece of equipment going to need maintenance? When do we need to have to close this plant to maintain it? That sort of thing. So using all that telemetry data from the IoT for predictive maintenance, so that the cost and impact of maintenance could be minimized. So that's generally a kind of a kind of a data lake IoT solution that is a sort of these are just kind of a bit of a flavor of the type of data platform that we get involved in building. So just in summary, then I suppose going back to what we said before, capture everything as long as it's cheap enough to do so, and understand it later. And and that's me. That's my quick whiz through data lake. So I hope that was okay for everyone, and happy for you to start the discussion.
Absolutely. Thank you, Andrew. Yeah, so Jonathan's had to leave. He says, very interesting, thank you. Some family commitments, so thanks from him. Yeah, so floor is open. Any questions or comments?
I think maybe what I'll do is I'll just stop sharing the screen, and then we can just have the the speak. If anyone wants to speak, you can see that.
I was just going to ask a quick question, if possible.
Yeah, sure.
And that was just around the type of industries that you commonly see using data lakes over just standard blob storage.
So that was just an example. Each industry has their own thing. So, for example, if you look at an e-commerce, big e-commerce site. So, let's say it's something like ASOS. They'll be running analytics on their website so that everyone, so they'll be tracking how far people have scrolled down their screens, where their mouse has hovered, what they've clicked on, all those sort of things. So they'll be generating tons and tons of that type of data. And they'd be storing, and that's the sort of thing they'd be storing. Looked at last month, at Tom's presentation, where he was talking about all that online advertising data, and just all the websites with all the banner ads, and how people are reacting to those. So all that whole world of advertising, again, similarly, it's just like there's just tons of information in there. It depends very much on each type of business or each type of discipline has got its own storage needs. But generally, as a rule, we in the past it was just too cumbersome to store it all, whereas now it's actually achievable to store things in those sort of quantities. And I think that's one of the big differences. So actually, Daryl, I know what sort of examples of sort of big data in oil have you come across so far? There must be, kind of think about the amount of sensors and all that sort of thing that are going on there. They must have quite a lot.
Yeah, well, without giving away any trade secrets, I mean, if you imagine a typical oil well, they have IoT devices under the sea attached to the drill heads, all the pipes going up through to the platforms. They measure the flow of everything, the pressure of everything, as well as the condition of all the equipment along the process as well. And even before then, they're crunching tons of data in terms of all the different mapping and geological surveys and things that they can get their hands on to basically use as much technology as they can to identify potential sources before the competition. So that's one example in oil and gas. But as Andrew said, just in the last 10 years, I think I worked for different clients, and some of those have been in advertising. So as Andrew said, in terms of web advertising, for example, everything you do on the internet is being tracked in terms of where your mouse is going, how long it's hovering over a certain area, whether it's clicking or not, the amount of time you're spending on the site. Equally, in terms of social media, I worked with marketing firms who literally track everything in terms of right the way through to, I think again, Andrew said, semantics. So the tone of voice that's being used in written and any video or audio content, as well as what's being said and reactions you might be able to track as well. So yeah, absolutely, the amount of data that is just being generated by us humans is phenomenal, as you said at the very start, Andrew. And yeah, I think every company now, I think it's been well said that every company now is an IT company, pretty much. They've got an IT function, and I would say in the last 10 years, most companies have now got a data science division or function within them, because they realise the power of the data that they hold or they can get hold of to use to their competitive advantage.
Brilliant, thank you.
Okay, everyone, thanks for listening. We've ended the recording there because that was the last question we had, and the rest of it was just the ad hoc discussion at the end of the meetup. So thanks for listening to that presentation, and thanks for everyone that took part. And we will see you soon on the next one. All right, thanks a lot. Bye now.